Well, thank you everybody for showing up. Got lots of viewers in the house. Welcome to the progress report for July 2019. It's been a long time since we've done a last demo of the programming language. The last one was actually in June 2018, so it was a year and a month ago. Why has it been so long? Well, sometimes I like to change up the pace. You know, for a while I was doing a demo every month or every 3 weeks sometimes. And then I just sort of felt like not doing it that way. But also, there were some shifts in priorities for a while. So I'm going to explain what all that was. So, you know, at some time in January 2018, I was like, okay, totally. By summer, we're going to be in closed beta, summer 2018. We're going to be in closed beta. It'll be awesome. And then, of course, we didn't do that. So let me explain what we did instead of those things. From June to December of 2018, we focused mainly on the game that we're making in the language, not on the language itself. That was a pretty big change in priorities. It was motivated by just production and schedule stuff, right? It was time to build out a bunch of levels in the game, and we had some interns coming on who were going to do level design stuff, and the gameplay code wasn't ready and all that. And so the majority of my time and other people who are using the language went toward getting the game ready, which might sound like it doesn't have anything to do with getting the language ready, but actually really it does. So for people who haven't been following along too often, this is a serious game that we're going to ship commercially. It's a serious body of code. It's about 100,000 lines, give or take, you know, depending on, you know, whether you count white space or whatever. And I think that that's an approach that people making new programming languages don't usually take, right? They usually will write some demo programs. They'll give you like some libraries, but they're like small bits of code. And what I wanted to do was base the decisions in this language on real experience that we get with real sizable programs that are complicated and that give us some problems that are not easy to solve, right? You know, it's very easy to take a 20-line program and say, wouldn't it be cool if you had a programming language feature that makes this 20-line program into a 12-line program? That's awesome. But it's another thing to be like, okay, we've got this 100,000 line program. What are the problems that we actually face from minute to minute? And, you know, how do we solve them? And so this June to December timeframe, there was a significant amount of programming on that, just building out the code and using the language features and getting comfortable with them and figuring out what's working for us and what's not, and what matters and what doesn't, right? So I could show just real quickly, it's not super relevant, but you know, there's 600 people in the audience, so I don't know who has seen what, but you know, this is the game that we're working on. It's a puzzle game. You know, it's 3D. It's got the various things that you might expect a 3D game to have, including, you know, built-in editor where you can move stuff and, you know, load levels and mess them up and have different layers of what's visible. And let's go to another level. That one in the screenshot, you know, was this one. So, you know, it's a real program, right? Like all of this is written from the ground up in the new language with, you know, a few things. There's a few exceptions where we call out to libraries that are written in C, mainly for stuff like, you know, loading JPEG files or compressing texture maps and stuff like that. And interfacing with, you know, graphics APIs in order to render. Okay, so we did that. We focused on that for a while. Let's do this a little bit out of order from the slides that I have. Then from January to May 2019, I shifted the majority of my time back to working on the compiler. But instead of doing new features, I became very concerned with making sure that what we had was as high of a quality as possible. So I was working on bug fixes a lot of the time, and I was working on rewriting parts of the core of the compiler, right? So I was really scared. Like, I really like the polymorphism mechanisms that we have in this language, like our equivalent of, templates in C++ and so forth. But I was really scared by how complicated the implementation of that had become internally to the compiler. And by scared, I mean, every time I wanted to go change something, like fix a bug or improve a feature, it would sort of turn into a quagmire of not being sure exactly how to do things, and not being sure exactly how to add things without breaking things and so forth. And so I said, okay, that has to get rewritten. There's a dependency. We'll actually talk about this in a few slides, but the compiler is built on this dependency pipe architecture that I came up with in 2014, which is part of how we do the nonlinear code compilation, right? So the compiler figures out all the dependencies between things in your program. You don't have to organize those in any way. That's great. It makes what the compiler does more complicated, though. And the dependency architecture that I picked initially, it's not really a surprise, is not the best way of solving the problem. And sometimes you have to learn that through experience by developing things and looking at them very closely, looking at the problems that come up and seeing the best way to solve them. And so I spent some time rewriting portions of this architecture. It's not very easy to just snap your fingers and change it, though, so it's still there, just in a simplified capacity, right? So during this whole phase of increasing robustness and bug fixes, and there were some feature implementations, but they generally weren't anything huge. And the focusing on the game and making sure things were good in the game. The compiler still got 20% bigger from June 2018 to July 2019, right? If you do a line of code count on it, this isn't all the files in this bitmap. This is just an example. These are the biggest files, actually. So hopefully all that size has gone into a good place, right, in terms of robustness. Hopefully it's not bloat. I don't think it is. Many times during the past year, there have been times when I would just go in and delete sections of the compiler. So I like to think that we're keeping it in good order, relatively good order. Then, okay, also during this period, I would say starting around January or February, I had this idea that there were two main features that we wanted to do before going into closed beta. One was the revised module system, because the one that we had so far was very simple. And the second one was the macro system, right? So I started doing the module system earlier this year. And it turned out that that was also kind of scary. So again, because of this nonlinear compilation architecture and because of some of the other features that we have. So we have a very flexible using operator. We have static ifs that are built into the language that evaluate and then put things in namespaces, but they're structured. They're not textual substitutions like in C. Like, all these things mean that the language places a lot of functional load on its core organization of namespaces, right? You would think that like a namespace in a language would be really simple. It's just an array binding a name to a value, or like a hash table if it gets big. And that is what it is, but like all the complications involved in what needs to happen when things are ready to be used and when they're not, it just got overwhelming again. And so that was more rewriting of that kind of stuff. And I put a very high priority on that because around that time, I became really concerned with complication in software. And the last thing I wanted to do was make more software that was too complicated for what it did. So I spent a lot of time I was sort of treating the internals of the compiler like a Zachtronics game, if you've played any of those, like Shenzhen.io or Opus Magnum, where you come up with a solution initially, but you can often simplify it very drastically after you've approached the problem for the second or third time. And so I was doing that. And so the namespace system has definitely gotten simpler. It still needs some revision, but it's in a much better place now. And so again, that was one of the things in the compiler that I was scared of for a while, and I'm not really scared of it now. Anyway, if you want to see my my angle on why complication in software is bad, you can see this talk, Preventing the Collapse of Civilization. It's on YouTube. Many people have probably seen it, I guess. Okay. Now, more recently, like in the past, let's say, month or few weeks, there have been some more simplifications that we've gone through and done that are significant. So I want to cover them here. And this extends to features, like cutting features that we had. The first thing is we removed constructors and destructors from the language. I implemented these a while back, and my strategy was to try to do them in a way that would be much simpler than what happens in languages like C++ or D, but to still get good use out of them. My idea was, hey, pretty much everything in the language is going to be what C++ calls plain old data, but we'll have some special cases where you have constructors, initialize things that are on the stack, and like destructors that'll clean up memory or something. And like I said, though, I don't want these kind of decisions to be based on ideals alone or just what you think is a good idea. I want it to be based on experience. And so a few weeks ago, I went through and did an analysis of like where in the modules and in the main program, in that game, and in our other test programs, where are we using constructors and destructors, and what are we using them for? And it turned out we weren't really using them for very much. And the things that we were using them for was mostly covered by defer if you had macros. So like most of the time, we wanted to be able to do something like just push some state and remember to pop it when the scope closes. Whether that's like, here's an identifier in the logging system that tells you what context we're logging from, or here's like lock a mutex and then unlock it when you exit this scope and that sort of thing. And it's really much cleaner, I think, to use a macro, and it's more self-documenting. It's less invisible and less surprising, right? And the other thing was that constructors and destructors added a significant amount of weight to the language. I didn't like all the complications involved in running constructors for global objects before main, right? And like the surprises that could happen there. And so now those things are gone. And we'll see how it goes. We'll see if we become sad about any of this. But so far, I'm not sad. So far, I'm happy that we did this. We tried it. We tried. I would say, though, this is not necessarily a permanent decision. If we come up with, in the long term, a design for some constructor-like feature that solves problems and isn't complicated and doesn't create more problems than it solves, then we would consider adopting that again. But for now, it's out. There's no such thing as that in the language. This opens the door for, I would say, us getting more serious about some things structurally. Like one of the main things that these are actually used for in real code is you have your destructor free memory, right? You allocated, like you've got a tree data structure and the nodes are separately allocated on the heap, and you destruct a node and maybe it reduces a reference count, or maybe you happen to know that there's no loops, so it like frees its child nodes or something, right? So the thing is, A, that kind of code is very slow, and B, it's complicated. Like having these destructors and having to think about when they fire and stuff, It's more lines of code and it's actually complicated. And if you've been programming in an object-oriented language, so-called object-oriented language for a long time, you've kind of got Stockholm syndrome about that and don't necessarily think about it, but it really is a lot of stuff. And it's a much more simple programming paradigm to think in a different way. Like, for example, hey, this tree or this module that generates these trees has one memory pool per major operation that I do, and I go and generate a bunch of nodes and compute the result and use the result and then free the entire pool, right? A, that makes the code a lot simpler. B, that makes the code tremendously faster. Well, both the module, because it doesn't have to free stuff, and the rest of your program, because you're probably not allocating all these different things in the middle of a heap full of other stuff, right? So the memory locality of the things that are on your general heap is improved by the fact that you're not throwing this other junk in there. And so I want to get more serious about making that the standard way that people do things, or I don't know this standard way, but a very common paradigm with which things are done, and looking at what we should do in terms of language features to help with that, right? Obviously, if you don't have destructors that free memory, one thing that could happen is you forget to free memory. But that just means we should be very serious about making it very easy for you to know when you failed to free memory, right? And we've got some ideas about language features that nobody else really seems to have done that would make that easier or nicer or more user-friendly, and we'll see how that plays out. But we'll demo that when the time comes. Okay, other features we added, if you were following along the live streams, you may have seen this. We've got intrinsics for a bunch of things, you know, CPU-specific instructions like atomics and whatever. We'll demo those, but that's a change to the compiler architecture because we didn't have this concept of intrinsics at all, and now we have it. It's worth pointing out that these are not like magic substitution intrinsics. So like, you know, C compilers will often substitute libc's memcopy for their own memcopy or something secretly. We don't do anything like that. Like, something has to be declared as an intrinsic for it to become one in your code. We're about clarity, like absolute clarity in the way these things happen. One major thing that happens that's very good for long-term code health of the compiler is I put CRT dependency removal here. That's not exactly the right explanation for what it was. But basically, for the whole history of the compiler, we always had sitting around in the background what we called the runtime support object file. It was a .o file compiled from some C code. And because it was compiled from C code, we had to have a different one for every operating system. And there were some other complications that meant we had to have more than one often per operating system. So that was really annoying. And, you know, in the very beginning, this was just something that helped us get the compiler off the ground. Like, we can call into that, and there's a bunch of code in there. Like, initially, it would like open OpenGL windows and stuff. Like, I think in the very first demo that I did with the Invaders program, that like created a window and drew some Galaga guys and whatever. I think it did it by calling into that C thing. But for, you know, early on, we got most of the high-level code out of there, but it still did low-level stuff. Like, if an assertion fails, the routine that like prints out where the assertion failure happened was like in there. And so over the past month or so, I got rid of that. So we no longer require any code written in C to compile a program. So that's good. We do still use a couple of C runtime functions as a matter of course. So it's not quite possible to link a program without CRT, but we're almost there. So the main thing is, you know, we use malloc, and we use sprintf or A to D or whatever it is to convert, or D to A, convert a floating point number to an ASCII string, both of which are not that hard to substitute. It's just, you know, we haven't done that. So once we do those things, all dependencies on the CRT will be gone. Now they're mostly gone, and they're replaced by runtime support, which is now native to our language. So I can show, this is the file now that has all this stuff, and it's about 300 lines. This gets linked for any program, not linked, but compiled in for any program that you build. And you know, it's got some very low-level routines, like if we want to write a line number, if it's less than 0, write a minus and then write a non-negative number. Like this is just kind of like this is not code that you want to hang out in very often, but it's like way down at the lowest level. It has very few dependencies, and it's what happens, you know, it's what you call into to print an error, or, you know, if you're going to panic, you know, if a bounds check failure trips, then we have to tell you what failed and where. You know, it does that sort of thing. So that's what these 300 lines do. We got rid of dependencies on the Microsoft compiler being installed. So back in time, we used to, we still use the linker at the very back end, right? Either link.exe or LLD. Even if you're using LLD, LLD needed to be able to find things to link against back in the day. So we needed, there was this thing called the Visual, what was it called? Like the Visual Studio Command Shell or something that had all the environment variables set in Windows that would tell you where all these programs were and libraries were and stuff. And Microsoft made it with new versions of Visual Studio harder and harder to use that consistently. And it seemed annoying to require people to install enough of Visual Studio to have that running. So we did an architectural change where we don't do that anymore, right? We basically search for the Windows SDK and the Visual Studio redistributable ourselves, which I believe is the common approach that everybody does now. It's a substantial amount of code. We released that code as Microsoft craziness.h on Pastebin. It was a very, what would you call it? Not a very formal method of releasing some code. But that just does this search for this stuff. And this was just sort of my version of, we based it on somebody else's version and tried to simplify it and cut it down. So that was successful. So now you can run, you still have to, unfortunately, if you're going to link against Windows libs to run on Windows, you need to install the Windows SDK, but that's a free download. And you want to install the Visual Studio libraries, well, for now, because we still do have a little bit of CRT dependency. But also, if you're going to link anything that was compiled in C, if it wasn't very carefully compiled to have no dependencies, which I would recommend, then you probably need to link against these anyway. And so, you know, we search for these on install now. So that's good. So I was talking about the dependency pipe system earlier. It used to have these different stages that your code would go through, right? You would start, it would get parsed. That wasn't really a pipeline stage, but code gets parsed, and then it goes through like type analysis, sizing, sending messages to the user program, holding the things until the messages are responded to, building the bytecode instructions, patching the bytecode instructions, being ready to run, and then being output, right? And it's just complicated to have all these stages. And like I said, this architecture ended up not really being the right thing for esoteric reasons that it's probably not worth going into right now. It's just like the model was very clean initially, like, oh, somebody has dependencies on other things that are waiting to build, and you pass a pipe when all the dependencies for that pipe are clear. It sounds very simple. It's not very simple. And it's not even correct in the long term. And so you end up having to do other things anyway. So we've removed a few of these pipeline stages this year. So it used to be 8 stages. It's down to 5 now. I think we should be able to remove run eventually. I actually have a slide here. We should be able to remove run, maybe builds, although I'm not sure why I think, oh yeah, because it doesn't have to be a pipe. Like if I remove all the dependencies and stuff, it can just go through this process without it being a pipeline stage. And then the message send as well, I think we can get rid of. We'll see though. Over the course of the past year, the test suite has been growing. So every time we fix bugs, those go into regression tests. And also we just have more demo programs and test programs that the other guys have been writing. And so that helps us make the compiler better. Why do I still have the cursor up? There's just simple stuff that you always should be able to do that we now have test programs that do. So for example, you can build a DLL or a library instead of just an executable. You know, that was always on the table to do that, but we just never kind of bothered, and now you can do that. You can build, you know, a DLL and call into it from a C program. That works. We have demos that do that. And because you can call into it from a C program, you can call into it from anything that's able to call the C calling convention, because that's how you get in to the system. We've started looking at the quality of output code from the LLVM backend in terms of efficiency. Not too much yet, but we've actually started doing that. So you might think like, what do you mean? You just put stuff into LLVM and then it's automatically fast. And it's like, not really. You have to like, you know, sort of do your best to tell LLVM what's up and what's legal to do and what's not. So right now we do have some times. So LLVM has this extra annoying thing too, where the code that it generates initially is all like memory copies all over the place. And then it tries to optimize those out. And you really do need to give it as much information as possible to optimize those away, or else it won't. So we've got some memory copies there that we would like to get rid of. We're looking at that. And there are language semantic questions that we need to decide that may have an impact on code quality, like what exactly is the parameter calling convention? Right now, what it's been in my mind the whole time is that when you pass a large thing like a struct to a function, it's either by const reference or a copy, but you don't know which. So the compiler is sort of free to assume the best of both worlds. It's free to assume no aliasing, right? Because it could be a copy, but it's free to pass a const reference for speed reasons if it wants to. The thing is, we need to figure out how to tell LLVM that, and that'll help. So that kind of thing, we're starting to do that work, and we'll see how it goes. We're using the language a lot more internally. So we have continuous integration servers that run every time we build the compiler or that game that I just demoed or another game we're working on in-house. Every time we check something into source control, it rebuilds it and runs the tests and all that. And that used to be some scripts that had to be different on different operating systems. Now it's all written in this language. And yeah, we're still refining these systems. It's relatively new that we've switched over, but we are using them for relatively serious things. Temporary storage, you know, it's maybe not worth talking about the details here. Maybe we'll talk about it in the next demo. We decided we're going to change the way temporary storage works a little bit to make it more user-friendly. It's still one of my favorite features in the language, but we're going to make it better. We may, along the lines of this simplification that I've been talking about, remove this custom operator identifier feature. You know, it only saves like 300 or 400 lines of code in the compiler, or actually maybe even less. Maybe it's like 200. I don't remember. But we don't hardly use it at all. And the times that we use it, like these are the 3 lines of code that actually do this. So the way that this works is you can make like a unary or binary operation out of any procedure by like quoting the procedure name. And that's one of those features that seemed cool, but like it's not Yeah, right. I mean, if we're going to do something about this, like this, maybe we should reappropriate quote to do something like the C# link syntax or whatever, and make the C# people happy instead of this. I don't know, but we'll probably remove that. Although if we replace it with a different feature, it probably won't reduce the compiler size at all. Anyway, so in terms of concrete milestones as well, until recently, we never bothered cross-compiling for any other architecture. We always just assumed x64 and the operating system that you were building on is the operating system you were targeting. Recently, in-house, we got executables up and running on the Nintendo Switch. I would like to show you that. We have a nice demo video where we run a simple program that does some stuff on a Switch dev kit. It's just, changing the screen color and responding to touch events. However, Nintendo has told us that we are not allowed to show a picture of a Nintendo Switch development kit. It is illegal for us to do that. Even though there's nothing special about it, it's a Nintendo Switch development kit. We can't show you that. So I just have to show you a black screen with text that says we have Switch cross-compilation. All right. So write a letter to your congressperson if you're unhappy with Nintendo not letting us show you that. It's cool though. And so, this is definitely, as I mentioned earlier, we want to ship this game on multiple platforms. Some of those platforms are going to be consoles. At some point, we have to do the work of getting them up and running on the consoles. And so, yeah, this was the first major step in that. Now, this is just getting an executable on there, right? To render a complicated game like the one I showed, you have to have bindings for the graphics API, and you have to use them correctly and all that stuff. And we haven't done that yet. But we do have the executables up and running on the device. In terms of the modules, so whenever we write example programs or the game or tests even sometimes, when there are things that are easily breakable into modules that we think will be useful for other people, then we do that. If you go into our modules folder, we have about 85 modules that provide generalizable functionality. They're in various stages of completion. Some of them are basically done, and others are relatively early prototypes. And I would class these as doing two different levels of functionality, right? There's the one that does relatively basic stuff that you would expect any language to ship with. So like string manipulation, basic data structures like hash tables, right? Files opening and closing and whatever, and multi-threading, like ability to create threads and whatever. So we've got that stuff. But we've also got higher level stuff like, here's how you render with OpenGL, right? Here's how you read mouse and keyboard and gamepad input. Here's how you play audio. And we're going to ship with all that too. That's not new news to anybody who's been following along for a long time. It's just to say we have a substantial amount of code for this sort of stuff by now, and it's still getting bigger. So it is still the case. We're on the road to closed beta, and the module system and the macro system are the two main features that I want to do before we hit that. Both of these have had a substantial amount of progress. The macro system, in fact, over the past week, if you've seen the live streams, we have substantial macro functionality now. It's pretty good. I'm excited about it. I like what it does for us. I won't go into detail here because that's going to be a whole separate demo. Let's talk about demos, right? So this is just a status update. So we're not really demoing compiler functionality yet, but we're going to do a few of those like we did in the old days. This is the roadmap of that. The first demo might be like a miscellaneous feature demo. So, smaller things that are not major systems, but things that are cool about the language that have been added or modified. I'm not 100% sure we're going to do this one, but it's likely. I just need to look at what are the miscellaneous features that have been done, how demoable are they, how interesting are they versus things that you just wouldn't even bother to mention. And if there are enough, I'll put those together and do that demo. if we do that, that'll be a week from now, probably, approximately a week from now. The next thing to demo will probably be the macro system and the new iterators. We have much better iterators than we had 2 weeks ago. They're actually fun now to use and to write, and they're not large amounts of code. So that'll be a fun demo. And then a little further out, so the macro system one I want to do within a month. It depends. Like, we could do a demo for it now, but there are more macro-related features that I want to do, and it's unclear how long those will take. And then we'll do a module system demo. That one is probably a little further out. I don't know when. It's just because the macro system is a higher priority, because the macro system gives your program new features that it could use, and it's good to like plan those out and get those in. Whereas the module system changes is more just like cleaner organization for the program, and it makes your code less amenable to rot over time, which is a big problem in the world of software today. So yeah, that'll be the next demo after the macro system, probably, if we hold to this schedule, which maybe we will, maybe we won't. For anyone who's here and hasn't seen a lot of this stuff or doesn't know what I'm talking about when I refer to other things, there is a YouTube playlist that you can watch. It's called A Programming Language for Games. Hopefully you could find that by searching for it. There are 55 videos on there. This is going to be number 56 or possibly 57 if the Q&A is long enough to make a separate video. It goes back to 2014. The first couple videos are probably a little too old, I would say, but the third one is the very first compiler demo, and that one is probably worth watching. Anyway, I have the YouTube tab open. I could show you. So all these videos. Now we also have a website, which I still haven't done the work to OK and put up, where we have annotations for all this stuff. Some of these videos are old enough that they're not really, for example, one of these is a constructor demo, and we just cut constructors, so you don't want to watch that one. So hopefully we will put that up soon. It's just the thing about that is it's very careful the way that we introduce this language to the public and how we explain what it's for. And it just takes a little bit of effort to figure that out, and it's hard to do correctly. That's all. That's why we haven't put it up yet. But I think that may happen soon, if enough people bother me about it. And that's the last slide that I have. So like I said, we'll do well, is it the last slide? My focus is on the wrong thing. Yeah. So as I said, we're going to do a feature demo eventually. I think for now, we'll do questions and answers. So on topic, questions and answers about the language, the feature set, the roadmap, etc.